Bharat Electronic will now present their case study, which is a holistic breakthrough project involving multiple stakeholders across the value chain, executed in a challenging situation, resulting in indigenization, shortened delivery, resource reduction, and doubling of exports. I now invite the team from Bharat Electronics, comprising Mr. Ganesh Kumar, Mr. Krishna Kishor, and Ms. Maiju Abraham, to share with us on how they went about meeting this challenge.
We are from Bharat Electronics Limited, a Navaratna Defence Public Sector under Ministry of Defence, Government of India. We are pioneers in defence electronics and safeguard the nation by in land, sea, and airspace. The Military Radar Strategic Business Unit of BEL empowers nation's defense forces by providing state-of-the-art battle surveillance systems and advanced air-fire control radar systems. Our team consists of Mr. Shashank, Mrs. Maiju Abraham, Mr. Kishor, and myself, Ganesh. And today, three of our team members will be presenting the case study on breakthrough improvement in the lead time for export of Radar X systems. Before jumping into the case study, I would like to take you through the journey of Radar X. You may remember in 1999, the Kargil War, 80% of our casualties were because of the enemy artillery fire. At that time, we didn't have an answer, for which what we had was an old British radar which is not suitable for mountainous terrain. This was a major setback for India as well as Indian armed forces. This created a huge void and the requirement to develop an indigenized radar which is help our armed forces and suitable for mountainous terrain. After 5 years of research, LRD, R&D wing of DRDO, and BEL jointly developed Radar X. In 2010, the first prototype model was manufactured in BL and it was put into trials at various locations. Now, what is Radar X? A Radar X is capable of locating hostile enemy weapons like guns, mortars, and rockets. It is a mobile radar system which helps our armed forces to track the weapons. So let us have a look at the glance of Radar X.
Radar X has been primarily designed to locate weapons firing projectile type of rounds like hostile guns, mortars, and rockets. WLR, in its secondary role, can track and observe the fall of shot from own weapons to provide corrections to own fire. The radar vehicle, along with power source cum byte vehicle, forms the configuration of radar built to operate in all terrain and weather conditions. The location and tracking of the requisite targets is handled by the advanced algorithm and state-of-the-art hardware. The ability to locate enemy weapons from its round and transmit the data of the required target to the counterfire elements for retaliatory strike before the target is redeployed is the key feature of the radar.
Thank you. Coming back to the case study, after successful evaluation of Radar X in 2015, Bharat Electronics Limited had bagged order for 30 radars for the supply to Indian Army. Now, during the 2016, the first of production model was ready, and subsequently the 30 radars were successfully delivered to the Indian Armed Forces, and it was inducted between the period 2017 till 2019. And as the Radar X manufacturing was coming to a close and the supply to the Indian Army was coming to a close, then we BEL looking out for the new orders for the equipment. So Military Radar SBU was particularly looking for the avenue to tap the export business potential for its sustenance. So the Radar X has been displayed at various international defense expos and forums. On one such occasion, in 2018, Armenia have seen our product in one of the defense expo at London, and they were very keen and interested, and they have also witnessed the firing trials of Radar X at Pokhran, and this was major event, and it was a major breakthrough for BL and MR SBU that on 25th May 2019, Armenia signed a contract with BEL for the supply of 4 sets of radar to their nation. Now, it was a proud moment for BL and MRSBU, as once upon a time we were looking for a radar to help our armed forces, and now we are providing a solution and capable of developing one radar, and we are exporting that radar. It was Bell won the contract against global competitors, and Armenia is one such country, that is European country, which is the first European country to procure a defense equipment of worth 40 million from India. And this had a major business impact on BL, as we have to export a top quality project because it was our pride. So, what is the challenges here? Even though we have delivered 30 systems and commissioned to our Indian Army, now the customers are different, and the challenges what we have to face is different, and their needs is different, their language is different, their geopolitical scenario is different. Like this scenario, we have to customize our radar and tailor to their requirements. So the first bulk production model of the radar took almost 18 months to manufacture, whereas we had a major challenge to execute this export radar in only 8 months. From this point, how we could achieve the major breakthrough improvement in the realizing the export radar will be continued by Mr. Krishna Kishor.
Namaste everyone. The crucial challenge of bagging an export order for an indigenously developed defense equipment system was met. However, major challenges laid ahead. The standard lead time for manufacturing 4 number of radar X and the lead time as per the contract was 18 months. However, the customer requested for an early delivery. Considering the geopolitical situation in and across the country of the customer, the request was honored. The drastic reduction in cycle time from 18 months to 8 months was a major challenge for us. Meager change in productivity of couple of processes was not sufficient. The challenge demanded overall productivity increase in almost all of the processes. The equipment which has been deployed which has been evolved from past 20 years, that is 2 decades. Many issues related to obsolescence and quality had crept in. These had to be addressed. The equipment which has been already deployed across various parts of the country had to undergo frequent preventive maintenance for keeping the radar operational. Extending such a kind of preventive maintenance across the border was neither feasible by BL nor was acceptable by the customer. The equipment had to be deployed in a foreign soil, that to a non-English speaking land. The language of communication and operation was a barrier. The following are the countermeasures that we undertook to address the challenges. For the first challenge of realization in a short duration of time was addressed by following 3-pronged approach. The first one was to concentrate on the procurement process time, the second, long lead time of the vendor partners, and the third, the integration time. Procurement process time was addressed by undertaking 2 Six Sigma and improvement projects. The first one was to reduce the cycle time to access the contact details of the vendors from an average of 8 hours to a couple of minutes. This was made possible by building an online sequential query language based database of vendor details, and ease of access was given to relevant stakeholders through a .NET based user interface. This increased the sigma value of the process from 0 to 3.5. The second project which was undertaken was for optimization of the process of sending inquiry for the requirements, wherein the existing matrix-based structure was transformed into a project-based structure, wherein the processing of the PRs for sending inquiries was centralized. This not only facilitated us to increase the pace of operation, but also gave a better control over the process. The sigma value for the process increased from 0 to 2.9. The second prong was to address the long lead time of the vendor partners. The first item, antenna assembly, was manufactured from our Ghaziabad unit, which had a long lead time of 9 months. On study, it was revealed that major chunk of this time was eaten away for arranging for the raw material from Germany. After conducting vigorous surveys throughout the country and following stringent quality checks to obtain the Atmanirbhar Bharat, we were able to identify a local source who was able to arrange for the item in a much shorter duration of time. This helped us to reduce the cycle time for manufacturing the antenna assembly from 9 months to 5 months. The second item, that is slew ring assembly, is manufactured from our Chennai based unit, which had a lead time of 9 months. The major bottleneck here was machining activity, which has to be carried out on the bearing at the heavy vehicles factory Avadi. Multiple agencies were approached within the country to outsource and offload the load. With due regard said for the required volume, quality, and the time frame required, it was next to impossible to source within the country. We had to explore boundaries. Finally, we identified a source in Russia who was able to machine the same bearing in a shorter duration of time, which helped us to reduce the cycle time of manufacturing the slew ring assembly from 9 months to 5 months. The battery pack lithium ion was sourced from a foreign vendor. Due to the explosive nature of the material, the only way of shipment was through sea. This had a long lead time of 15 months. Efforts were put in to develop a local source, and we were able to contribute to the Atmanirbhar Bharat by developing it. And finally, we were able to reduce the cycle time from 15 months to 3 months. Additionally, we were able to save 4 lakhs. The third prong was to address the integration and assembly cycle time. An improvement project was undertaken for optimizing the assembly kitting and launching activity. Previously, the assembly kitting activity used to be initiated on having 80 to 85% of the material in stock after procurement. This activity was advanced to a much earlier phase of the process flow, wherein soon after the first round of MRP run and stock picking had completed. This gave enough breathing space to the project manager to address the issues related to the stock discrepancy or the quality of the raw material without hampering the speed of integration. The standard time to integrate one radar X was 15 days, and a unit mode of production was followed, that is one radar after the other, leading to 60 days of integration time. By designing multiple jigs and fixtures, templates, and SOPs, we were able to reduce it from 15 to 7, but still 7 into 4, 28 days, we didn't have that much liberty of time. We had to change the mode of production from unit to batch, wherein 4 teams simultaneously worked on 4 different radars in shifts, which resulted in drastic reduction of cycle time for integration from 60 days to 7 days. This also helped us to consolidate the consignment. As the country of the customer was a landlocked country, we were able to ship it only through air shipment. Due to the consolidation of the consignment, we were able to reduce the air flight time from 90 hours to 54 hours, which led to a drastic reduction in carbon emission of almost 7 tons. Next challenge what we faced was crossing the post-delivery hurdles. The hydraulic stabilizer is a very important part of the radar X. It plays a crucial role in deployment and operation time by providing the required elevation and stability to the antenna assembly. It has a major impact on the radar output accuracy. Due to the presence of rubber items like oil seals and gaskets, frequent valve failures, and oil contamination and oil leakages, this system was prone to failure. To counter this, PL had to undertake preventive maintenance. Extension of this kind of preventive maintenance on a foreign soil was not an option. Hence, the project manager initiated multiple brainstorming sessions with the design agency, internal D&D, and multiple vendor partners, and finally was able to change the design from a hydraulic system to an electromechanical system. The major advantage of this being 3 years of maintenance-free life. It was motorized and autonomous compared to a manual mode of, and it required a highly skilled operator in a hydraulic system. It had a less impact on environment due to the less usage of oil. Finally, it was a rugged and much more reliable system. The third challenge is Zdravstvetya, mein kohit was project, meaning, hello, I want your product. We were as baffled as people in this seminar right now for hearing somebody speaking in Russian for the first time. All the technical manuals had to be converted to Russian. You may think it's a matter of seconds, you can hire an agency to do that. No, it was a highly classified project. We didn't have the liberty to trust a third party. The need for developing an internal competency was sensed by the project manager, and by taking the approval from the management, we were able to inculcate 90 hours of Russian language training program for the project engineers. Because of enhancement of the internal competency, not only we were able to change the language in the technical manuals, we were able to redesign the software and inculcate Russian in all the user interfaces. This was a customer's delight. The challenge number 4 will be explained by Srimati Maiju Abraham.
Hi everyone, I'm Maiju Abraham and I'll be taking you through the challenges in production, especially related to obsolescence and quality issues in the subsystems of the RadarX, like system computer, 20.1-inch display, synthetic display subsystem, programmable signal processing unit, and the beam steering unit. If you're wondering why these subsystems are a challenge, let me explain. You can imagine a tiny piece of shell flying in the air and a narrow beam has to be accurately placed on it to track. The placement of these beams are done by these subsystems. Quality issues in the subsystems because of obsolescence and considering the fact that critical parts of the subsystem come from foreign sources makes it highly challenging to realize these subsystems in time for the RadarX export. The first case, we have a look at the obsolescence and quality issues of the system computer. With 47% of failure in the system computer and 91% of the failure occurring during the production test procedures, with different types of issues happening at different conditions like vibration, damp heat, and high temperature, it became very difficult to isolate the root cause of the failure, and hence this was taken up as a Six Sigma case study. The initial yield was only 52.3%. Analyzing using cause and effect diagram and validating the causes, we arrived at one major potential root cause and two minor causes. With 80% of the failure in the VME chassis, we further analyzed and identified 3 issues in the VME chassis. The VME chassis is supplied by the OEM ELMA, which is a UK-based vendor, and is integrated with the help of external provider RTTS India. The first issue that we observed in the VME chassis is related to the power supply connector. The power supply connector inside the VME chassis, the pin of it was getting flared up during the crimping process. And this was resulting in an intermittent contact and disrupting the power supply in the system computer. To rectify this issue, we involved the external provider RTTS and introduced dimension checks at their end during integration. The second issue that we had was related to the wire shafting of the VME chassis. So during the vibration activity, the internal VME chassis was vibrating independently with respect to the outer chassis. And in the process, the wire bunches were rubbing against the baffle plates. And the sleeves on the wires were getting shaft off, as you can see here. These are the marks on the baffle plate, which has happened during the rubbing. So whenever the wire touches the baffle plate, there's an electrical short created, and this was disrupting the power supply in the system computer. This was because of an error in the OEM's process, and we involved the OEM ELMA in resolving the issue by providing insulating sheets and edging strips at critical areas like the fan tray edges and the baffle plates. We also did an interrelationship diagram to understand why some of the power supplies were permanently failing. With all the analysis and improvements done, we were able to get a good yield of 95.5% and savings of 18 plus lakhs and 600 man-hours saved. We were able to do improvements in the process and product of ELMA, who's a foreign OEM. The report from ELMA is as attached, and the process of the RTTS, the external provider vendor. Considering the lessons learned and the risk involved, we thought of an alternate sourcing, and our design teams, along with IUR, was able to provide a better solution in terms of a new system computer. This indigenization gave us a savings of more than 41 lakhs, and this was much better in terms of maintainability. The second issue that we see is in the obsolescence and quality issues of 20.1-inch monitor. This monitor is supplied by IRTS, a France-based OEM, and is integrated by RTTS Bangalore. The issue here was a high rate of failure in the 20.1-inch monitor, and considering the high rate of failure, almost 50%, we involved the OEM at BL to rectify the issue. The first issue was occurring in low temperature test, and this was because of the routing of an LVDS cable very close to the heater cable. And the OEM resolved this issue at BL by rerouting the cables. And the second issue that we had was occurring in the high temperature and damp heat. And this was because of the control board in the display. This control board was already on its way out due to obsolescence and was giving reliability issues. The report from IRTS related to the same is as shown. Again, we looked for an alternate source, and our design team, along with Paris Defense System, was able to give a different display system, which this indigenization has resulted in a savings of 17 plus lakh for 4 sets of radar X. The third case, we have a look at the obsolescence and quality issues of the synthetic display. The synthetic display subsystem consists of a main processing unit, a functional keyboard, and a 20.1-inch display. The main processing unit cards come from Adlink USA. The functional keyboard is in-house manufactured at BL, and the 20.1-inch display is coming from IRTS France, as we've already seen. The graphic card and CPCI card inside the main processing unit were having a high failure rate in environmental test. Low key response from the external provider and long lead time to resolve the issues from the OEM led us to look for an alternate source. And our design team, along with Paris Defense System, was able to give a much better solution in terms of a singular modular design integrated panel PC and with a much simpler keyboard. The earlier keyboard had complex switches on it, making it difficult to test and troubleshoot. This indigenization has given us a very good savings of more than 2.86 crores. The programmable signal processing unit subsystem has 2 PCBs in it, called as a DIF and DIC PCB. And these PCBs had multiple FPGAs on it. The FPGAs were obsolete. We looked for redesign, and our design teams in BL were able to provide a single board solution with a single FPGA on it. Similarly, the beam steering unit subsystem had components going into obsolescence, and design activities were taken in collaboration with an Indian source, and an improved product was designed. The indigenization have given us savings of more than 1.36 crores for 4 sets of radar X. To sum up the impact of these case studies, process changes resulting in cycle time reduction, alternate sourcing of material has resulted in cycle time reduction, given us cost advantage, and new designs of the equipment have given us not only cycle time reduction and cost advantage, but better maintainability, which has all resulted in improved productivity. This has resulted in also a direct cost savings of 5 crore plus, and the project could be executed in time as planned in 8 months. The project has not only illustrated that the productivity has improved, but also has had a sustainable impact on the environment through reduction in carbon footprints and elimination of waste. The project has contributed to BL's export business, rising to 48 million USD when compared to 21 million USD in the previous year. The slide here shows the various awards and certificates received from internal and external agencies. The process and design changes are in process for a new radar system, which is similar in nature, and we're expecting another 30 radars in the pipeline in the near future. And several other countries have shown interest in our product. In our endeavor to realize the radar X system, we have used the following tools and techniques and taken up methodologies like PMP templates, Six Sigma case studies, improvement projects, and design improvements, and has helped in reaping the benefit of cycle time reduction from 18 months to 8 months. With increase in productivity, we have got a savings of nearly 5 crores. And this savings was not only utilized to add resources to reduce the cycle time, but also to give a cost-effective product. Improvements were carried out not only in the processes of BL, but also in the processes of external provider, especially foreign OEMs and their processes and products. The best of all, the brand of BL has got a boost beyond the nation's boundaries and has facilitated expansion of business across the globe. And with this, we have supported BL's vision of becoming a world-class enterprise in professional electronics. Let me conclude by saying, managers, engineers, operators, employees of various departments of BL, LRD, and vendor partners from across the globe have come together to bring a towering symbol of Bharat Electronics' capability of marking its presence in the world of professional electronics by increasing the productivity and manufacturing a world-class defense system in a record time of 8 months. Thank you.